Hi, I'm Andrew Nordstrom, and this year for Science Fair, I decided to work with irrigation. Since a young age, my grandfather would take me out into the fields to help him irrigate the land. He used flood irrigation, which after reading recently, it's super inefficient. According to a study done by an organization called OECD, they found that 70% of all fresh water is used in agriculture. I found this number hard to believe since water is becoming a more scarce resource due to global warming. I decided I wanted to fix this issue using machine learning, LiDAR, and a lot of complicated math that I barely understand. The first thing I did to build my project is I used Cornell University's huge image repository full of plant images. I used over 50,000 of the images from the repositories to train my machine learning model. I then plugged this model into Google's Firebase. After that, I started working on the algorithm that would convert the LiDAR data into grayscale data. Grayscale data is a two-dimensional view of 3D objects. Since I'm not well versed in differential geometry or algebraic geometry, which are required to interpret LiDAR data, I ended up relying on code that I found on GitHub that already did this for me. After I figured out the LiDAR part of the project, the rest of the project was much more straightforward. I attribute the project becoming more straightforward to how well Google has documented how to use Firebase. I used a Node MCU with a few water pumps and water sensors in order to control how much water was being diverted to different canals that the system thought needed water. I then linked this to Firebase, and then from there I was ready to start testing. For my project, I set up 3 different regions. One used flood irrigation, one was fully autonomous using my machine learning model. The third planter was identical to the autonomous planter, except it used a different water source. I wanted to see if I could reuse already ran water in order to save water, in turn making the farm even more efficient. However, this didn't work very well. Due to the acidity of the water and all the debris in it, it caused the plants to stagnate in growth, and I believe this is because the water was a bit more acidic since it already ran through the soil. Of the 3 planters, the autonomous planter was the most efficient, using about a gallon of water a day, whereas the flood irrigation planter used almost 5 gallons a day. However, according to my machine learning model, the flood irrigation plants were slightly more healthy than the autonomous irrigation system. For how little of a difference the health score was, that the irrigation system that I created is a much more efficient method to watering plants than flood irrigation. I believe that if implemented, my system could save hundreds of thousands of gallons, if not millions of gallons. I believe my project might even be able to slow down global warming in some respect due to not as much fresh water being needed. This project really tested my patience. I made over 40 prototypes, fried 1 Arduino, and had to go through many different iterations of my design before I got a working model. I'm very proud with how my project turned out, and I'm excited to see where this research takes me in the future.